All right, so today we are talking about piecewise functions. This is 4-7 in your book. A piecewise function is a piece of a function. We are seeing pieces of functions. All right, as you can see in the graph, you'll see more than one equation and you see little pieces. The difference from today is yesterday's functions, which were step functions. Those two were piecewise functions. Only they were constant functions. They were y equals. They were horizontal lines. Today's functions, you're going to see more like mx plus b equals, you're going to see y equals mx plus b with a restriction. So the first thing you're going to see is how do we evaluate? Okay, so on the first problem, I know this is really hard to see, so I'm going to just kind of clean it up. There's a minus there. The first thing you do is they ask you to evaluate. Evaluate means find the value. So for A, we're going to evaluate when x equals 0. So the first thing we need to do is ask ourselves, what domain does that fit with? This one right here or this one here? Is it the first or the second? Where does that 0 fit? In what domain? Let's go, Lucas.
X minus 2.
It fits with x is less than or equal to 0. So it goes with this equation. So we take that equation and we say, when x is 0, we use that equation, x minus 2, but we're going to replace that x with a 0. And we get the f of 0 equals what? Negative 2. You got it? So I want you guys to find the f of 4. Now, pause the recording, figure out what equation it goes with, which function equation it goes with, and then tell me what is the f of 4. I forgot to record. Okay, so now we are going to substitute it in. Check your work. The f, when x equals 4, it goes with the other equation, and we should get 9.
Can't they go with both equations?
No, because x is 4 only fits with this domain. This domain says x is greater than 0. Yes?
So what he asked, does it go with it? What if, never mind.
Okay. So, we're going to try it again. Let's go with the f of 8. Which equation does it go with? The f of negative 8. Okay. Stephanie, what do you think? Tell me the domain first, not the equation.
F of negative 8 goes with 4x.
No, I said the domain. These are the domain right here.
Oh, it goes, x is greater than 5.
So negative 8 is greater than 5? Does everybody agree with that?
No.
So this, if it doesn't work with this, we don't use that. Where does it go, Stephanie? Where negative 8 will make a true statement. There's two. Is negative 8, if I put negative 8 here, is that a true statement?
No.
Stephanie? Okay, if I put negative 8 here, is this a true statement? So that's the equation I use. Do you understand? So I say the f of negative 8 equals 3. Is there anything I have to do?
No.
Why did the x disappear? Nadia?
The x disappeared because it has a slope of 0, so it's 0x.
Okay, plus 3, and so when I substitute in that negative 8, it's still going to be plus 3, and we get the f of negative 8 equals 3. Okay, let's try one more. What about the f of negative 2? What domain does it go with, Camille?
The is it the x plus 2?
I want the domain. I want you to read it by the domain.
If negative 2 is less than or greater than negative 2.
Less than or equal to x, which is
Which is less than or equal to 5.
perfect. So it goes with that domain. So now I'm using that equation. Is everybody understanding?
Yeah.
Negative 2 plus 2. So the f of negative 2 equals what?
0.
0. Is this clear? Okay, you guys clear on how to do this or no? Or are some people confused still? Okay, now let's go over to this. Now the first thing they're going to ask us to do is they're going to ask us to describe the domain and range. In order to do that, you must graph it. So the first thing you're going to do, it's almost just like graphing two equations. You make yourself a coordinate plane. Okay? Now mine's not going to look so perfect because I'm not on graph paper. Okay? We're doing this. Now you just have two equations you have to graph. The first one is y equals negative x minus 4. What's your m and your b? M and your b. Yes.
Your m is -1.
Negative 1 and your b is
Negative 4.
-4. So I start at -4. I'm not sure if it's going to be open or closed. I'm just starting at -1, 2, 3, 4. I put an open circle. And I'm going to rise over run -1. So I go up 1, left 1. Up 1, left 1. Up 1, left 1. It's supposed to be a straight line here. I can also go down 1, over 1. Down 1, over 1. Now, here's where I look at my domain. X has to be, they only want to see X. They don't want to see only X where X is less than 0. So this side, because here is where 0 is. So I'm only drawing from here. I'm only drawing from here up. Shh. Watching? Now the next one, where am I starting? Y equals X. What's my M? What's my B? Yes, M is?
M is 1.
1, B is 0. I'm starting at the 0. And I've got here, 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 here. I can do this. But this time my restriction says X has to be greater than 0. Greater than. So I'm only drawing where the X's are greater than 0, and that's here. Now, is this point filled in or not?
Yes.
Yes, because it's equal to. Now, look at it. What is the domain? Tell me about the width. What is X allowed to be?
Any real number?
Domain is X. It's all real numbers. Okay? What about the range? Quickly?
All real numbers.
No. Y, keep going.
Y is greater than -4.
Remember, it's all going to be up here. So Y is greater than -4. Okay, hold on. Okay, so I just had a question that people said, do I have to shade in? No, this is not an inequality. Forgive me because I am going to go back. All I really did was show you that shading to show you they only want to see the line within that boundary. So really, I should go back and get rid of that shade of yellow. Okay, and there's my line. We're only drawing the line on that side. Forget about the shading. That was just a temporary example. I should have erased it. I just want to see the line because x is less than 0. And then on the next one, when I draw the equation, I'm only showing the line where x is greater than 0 right here. Remember, it said x is greater than 0, so I don't want to see any of these points right here. Do you see that? I don't want you to see that. So now, when we talk about domain and range, the domain is the width from the farthest to the right all the way to the left. That's why x is allowed to be all real numbers. And the range is what is the minimum point or the maximum point. There is no maximum, but my minimum point is here. So for my range, I'm going to say y is greater than, not equal to, that -4. For my domain, we know that it goes on and on forever to the right and left, so we're going to say all real numbers. Okay? All right, so that's the second type of an example. We're graphing both. I'm going to remind you, I do want you to identify your M and B. Okay, so the next type of example is when we take the graph and we actually write the equation. So you have to look at each line, find the slope, find the y-intercept, and then create the restriction. So for the first line, I'm looking at this line right here that I just put a little mark on. We are going to say, what is the M and what is your B? My M is my slope, so I'm rising 1, running 1, so it would be 1, okay? And my B is positive 1, 2, 3. So I'm going to write, since it said write a function, we're going to call it the f of x. Now remember, since it's in pieces, we're going to use that half of a bracket. And I'm going to write the first one. It is 1x plus 3. Now I need to write what is the restriction. The restriction says I only want you to see the line when x, all these numbers for x are less than 0. So less than 0, not equal to, because that dot is not colored in. This dot here is not colored in. Now I'm going to look at the next problem. Okay, that is where we are. My M is, it's a positive 2 over 1. And my B is -1. So I'm doing the f of x, or y equals, right? It's, the slope is 2. I put my x in there, plus, oops, is it a plus? It's actually a -1. And then we're going to say if, this time I only want to see, you'll notice that every point on this line, the x's will be, here's this ordered pair is going to be 1, 1. This is going to be 2, 3. And this is going to be 3, 6, right? Let's see. 1, 2, 3, up 1, 2, 3, 4, 5. So it's going to be 3, 5. You will see all of my x's are greater than or equal to, because this is filled in, and we're going to say that is actually where my 0 is. 0, 1, 2, 3. So we're going to say x is greater than or equal to 0. We're looking at the width when we talk about domain. So that's how we write the piecewise function. If I were to be asked, let me erase all this. What if I am asked about the range? In this case, because this is going to keep going, the maximum height is going to go higher and higher, and the maximum, height below it will keep going down. The range in this case would be all real numbers. Okay? And then we've just put it into our piecewise function format. This is another practice graph if you want to pause it and check your work. And now, the last type of example, number 4, is similar to what we did earlier today, where you're renting something for 5 days. The rental company charges $50 for the first day, $25 for each additional day. Write and graph the step function that represents the relationship between number of X days and the total cost, Y. So let's make a table first. My X from day 0 up to day 1. How would I write that? 0 is less than X, which is less than or equal to 1. I pay $50, okay? And then from 1 is less than X, which is less than or equal to 2, I pay 75. 2, so now remember, if you write it like this, then that can really pretty much be your function, okay? What's my function going to look like? It's pretty much the same thing. That X is your restriction, and then we go and graph it. They want us to do that and then graph it. Let's look at how we graph it. Remember, cost is going to be on your y-axis. Your time is going to be on your x-axis. And we are doing a step function just like what we did for the parking garage. So this is what you're going to use to base your number 35 and 36. Since I already went over it so thoroughly earlier, you can check the other function on step functions, and we have a nice example there. And that's tonight's homework.